Problem 1, consider the following 3 data sets, and here they give you 3 sets of numbers, which they call A, B, and C. The question said, calculate the mean of each data set, the standard deviation, and which set had the largest standard deviation. So what I'm going to simply do is enter my data into my calculator. I'll enter the data from list A into list 1 of my calculator. For data set B, I'll enter it into list 2, and for data set C, I'll enter it into list 3. So what we're going to do is we're going to press the Stat button on our calculator, and then while Edit is highlighted, we'll just simply press Enter. And what I'll do is I'll run the one variable stat test for each of these data sets to calculate the mean and the standard deviation. So here, if we look at the data and analyze our results, here the mean for each data set is exactly the same. Here for each data set, the average is 10. So if you look at numbers strictly from what their average is, it doesn't really give you a great indication of what's going on with the data. Here we have 3 data sets with clearly very different pieces of information. The first, all the numbers are around the number 10. For the second, for B, all the data values are 10. And for letter C, you have a 10, but then you have numbers 1 and 19 far away from 10. Here the standard deviation, and for our class we're always going to use the standard deviation that's directly above the n value. So here we're going to look at that sigma of x, that's the Greek letter sigma, and that's the standard deviation. So here set A, the standard deviation is 2. For set B, the standard deviation is 0. Set C, the standard deviation is 8. Now what does that mean? Standard deviation just tells you how spread out the numbers are. Notice for data set B, the standard deviation is 0. That's because the numbers aren't spread out at all. They're all the exact same value, which is the mean. For letter A, the standard deviation was 2. For letter C, the standard deviation was a little over 8. The larger the standard deviation, the more spread out the numbers are. Set A, the data values are pretty close to the average. They're pretty close to 10. For letter C, the data values are spread out more because data set C has a higher standard deviation. For problem 2, the frequency table of the monthly salaries of 20 people are shown below. And what I did was I entered my data, my salaries, into list 1 on my calculator. And here I entered the frequencies, the number of people with each of these salaries, into list 2 of my calculator. And now I'm going to calculate the mean and the standard deviation. So here the mean monthly salary turns out to be $3,955. And the standard deviation, remember we're always going to be using the standard deviation above the n. So here our standard deviation is going to be $281.91. Last year, a small statistical company paid each of its 5 statistical clerks $22,000, 2 statistical analysts $50,000 each, and the senior owner $270,000. Here we need to find the number of employees earning less than the mean salary. So what we're going to do is we're going to go about finding the mean, the average, and to do that we're going to use the frequency list feature of our calculator. Here you see I entered in the salaries, the money in list 1, because that's what the question is asking me to find, salary. And here I entered in the frequencies into list 2. So the 5 statistical clerks earning $22,000 a year, the 2 analysts $50,000 a year, and the 1 owner $270,000 a year. What we're going to do is we're going to run the one variable stat test on the data, make sure whichever list has the actual data, in this case they're dealing with salary, make sure that has to be the list next to list, and then here my frequencies are in list 2. So when I go about calculating the mean for this particular company, the average salary turns out to be $60,000. So we need to find the number of employees earning less than the mean, less than this $60,000. Well, here I'm just simply going to be adding the frequencies for the $22,000 and the $50,000. Here, 5 people earn $22,000, 2 earn $50,000, so a total of 7 employees earn less than the average. Problem 2, in general, which of the following statements is false? And what I did to answer this question was I gave you 2 sets of data. I gave you the data 1, 2, and 3, so that's one set of data, and I'm giving you 1, 2, and 50,000. And what I did was, to kind of demonstrate the properties of statistics, I ran the one variable stat test for the 1, 2, and 3, and I also ran it for 1, 2, and 50,000. So letter A, the sample mean is more sensitive to extreme values than the sample median. Well, take a look. In this first set of data, I have 1, 2, and 3. The average, the mean, was 2. Here, I changed the 3 to 50,000, and now my average is almost 17,000. But if you look, the median of both sets of data, the 1, 2, and 3, and the 1, 2, and 50,000, the median still is 2 for each set of data. So this is true. The sample mean is a lot more sensitive. As this $50,000 number was introduced, the mean jumped up very large from 2. So that's going to be true. Number 2, the sample range is more sensitive to extreme values. Well, look at the range. That's the greatest number minus the smallest number. Here you have a range of 2 in this first set of data. For the second set of data, here you have a range of 49,999. So as the extreme value is introduced, as this 50,000 number is added, the range jumps up dramatically. But the standard deviation goes from 0.8 to 23,500, give or take. So the sample range is more sensitive to extreme values than the sample standard deviation. That's technically true because the range went from 2 to 49,000. The standard deviation went from a little under 1 to 24,000. So the range jumped up more than the standard deviation did. So yes, the sample range is more sensitive, but both increased dramatically with this second set of data. And here the answer to this question, which of the following statements is false? It's going to be letter D. Remember, the measures of central tendency are the mean, the median, and the mode. The standard deviation is not a measure of central tendency. Central tendency means if you have the set of data, the mean, median, and mode are usually in the middle of the data. They're usually in the center of the data. So that's why they're defined as the measure of central tendency. The standard deviation, that's actually the measure of spread, how spread out the numbers are. So letter C is going to be true, and letter D is going to be false. So that's why our answer is going to be letter D. Number 3, during the past few months, Major League Baseball players were in the process of negotiating with the team owners for a higher minimum salary and more benefits. At the time of the negotiations, most of the baseball players had salaries in the range of $100,000 to $150,000 a year. However, there were a handful of players that earned nearly $3 million per year. Which measure of central tendency, so we're dealing with the mean, the median, and the mode, might the players have used in an attempt to convince the team owners that the players were deserving of higher salaries? So the players want to convince the owners that they want higher salaries. So what we need to do, it looks like here we're dealing with the mean or the median. We want to know which of the two the players want to use. And what I'll do is this. I will make a hypothetical situation. I'm going to say, let's pretend that there are 100 players making $100,000. Because it says at the time of the negotiations, most of the baseball players had salaries in the $100,000 to $150,000 range. So I'm going to say, suppose there's 100 players making $100,000, and let's say there are 3 players making $3 million. This 3E6 is the calculator fitting in the number 3 million because 3E6 means 3 times 10 to the 6th, or 3 million. So it says most of the baseball players had salaries in the $100,000 to $150,000 range. And there are a few players who, via free agency, earned nearly $3 million a year. So let's say there's 3 players earning $3 million a year. Well, with that data, the average salary, so the mean, is about $185,000. But the median salary, the middle salary, is $100,000. So this question says, which measure of central tendency, the mean or median, might the players have used in an attempt to convince the owners that they, the players, deserved higher salaries? Well, if you're the players, you want to try to convince the owners that you need higher salaries. Would they use the higher value, the mean, or the lower value, the median? Well, if you're trying to convince someone that you need a bigger salary, you're going to use the smaller data value. You're going to use letter D, the median, to say, look, the middle salary is $100,000, we deserve more. If you use the average salary, these 3 players making $3 million, kick the average up by almost $100,000 more, $85,000. So here the answer is going to be the median because you're going to use the smaller data value. That's why the answer there is letter D. Problem 4, a financial analyst sample of 6 companies' book values were, and here they gave you the values. Here you need to find the sample mean and the sample standard deviation approximately. So I'll just enter this data into my calculator and get the mean and the standard deviation. Now, here the mean is going to be 20, and your calculator gives you 2 different standard deviations. And in our class, I've told you that we always use the bottom one. Officially, the bottom standard deviation, this sigma symbol, that represents what they call in statistics the population standard deviation, while this top one represents the sample standard deviation. When we do questions in class, we always use the population standard deviation. This one here is asking you for the sample. So here the sample is going to be 8.9. So here the mean is 20, and the sample standard deviation is 8.9. So here our answer is letter B. Problem 5, a sample of underweight babies were fed a special diet, and the following weight gains in pounds were observed at the end of 3 months. Here we need to find the mean and the standard deviation for the data. So here we'll just enter the data into a list on our calculator and run the one variable stat test. So here it looks like our answer is going to be letter E, the mean 4.67 and the standard deviation 1.84. Problem 6, the heights in centimeters of 5 students are, here we need to find the sample median and the sample mean. So here we'll enter the data into a list on our calculator and again run the one variable stat test for the data. So here we're going to have the mean. That turns out to be 169, and we have our median to be 170. So it looks like here our answer is going to be letter A. The sample median is 170. The sample mean is 169. Number 7. The test scores on a college algebra test are as follows. And here we have to find for letters A through D the range, the interquartile range, the mean of the data, and the standard deviation. Take a moment, pause the video, enter the data into your calculator, and I'll put the results of the one variable stat test up on the screen. And here just make sure your n value is 25. There are 25 pieces of data given to you. And here are the results of the one variable stat test. So here the mean, I'll start off with letter C. The mean turns out to be 88.16. Here the standard deviation, we always use the standard deviation above the n value. So here our standard deviation is going to be 10.5. The interquartile range, Q3 minus Q1, that's going to be 99 minus 80.5. So here the IQ turns out to be 18.5. And then the range, that's the max minus the min, so that's going to be 100 minus 67, or 33. So there's your answers for the first 4 questions. Now, what we now need to do is we need to find the number of data values that fall within 2 standard deviations of the mean. So what we're going to do is we're going to imagine our data on a number line, and it's all going to be centered about the mean. It's all going to be centered about the average. So here our average is 88.16. And what we want to do is we want to go 2 standard deviations. I want to go 2 standard deviations to the left and then 2 standard deviations to the right. And here, since our standard deviation turns out to be 10.5, here I'm going to be adding 10.5 twice and then subtracting 10.5 twice to get a range. So here's what I did on my calculator. I took the mean, 88.16, and I added 2 times the standard deviation, 2 times 10.5, and that gave me 109.16. And here I took the mean, I took the 88.16, and I subtracted 2 standard deviations. Because this one here says how many data values lie within 2 standard deviations. So when I subtract 2 times 10.5, I get 67.16. So now I have a range of data values. I have a range that's going from 67.16 to 109.16. And the question is basically asking how many data values are in this range. How many data values go from 67.16 all the way up to 109.16. And if you notice, the only data value which is not in that range is the 67. The 67 on a number line would fall to the left of the 67.16. So here, since we had 25 data values, the number of data values between 67 and 109.16, here the answer is going to be 24. Every test score except this 67 was in that 67.16 to 109.16 range. For letter F, now we want to know what percent of the data lies within one standard deviation of the mean. So here we need to try to figure out the percentage of the data values. We'll figure out how many data values and turn it into a percent. How many data values are within one standard deviation of the mean? So again, I'll imagine a number line with the mean, the average, right smack in the middle. And what I'll now do is I'll go one standard deviation in each direction. So here I'm going to be adding just one 10.5 and subtracting just one 10.5 from that mean, because it's all centered again around the mean, the average. So here when I add 10.5 to the mean, I get 98.66. And here when I subtract 10.5 from the mean, I get 77.66. So this particular question is saying what percent of the data lies within this range. I need to find, first of all, how many test scores are in between 77.66 and 98.66. And what I do is, sometimes it's easier just to count the ones that are not in this range. So 67 and 69, 71, and 75, those four lie less than 77.66. Starting with the 78, you are in this range. And then it looks like the 1, 2, 3, 4, 5, 6 hundredths lie outside of this range because the 98s are in 77.66 to 98.66. So it looks like we have a total of 4 plus 6, or 10, which are not in the range, which means if we had 25 data values, then 15 are between 77.66 and 98.66. But the question didn't say how many test scores are within one standard deviation. It said what percent of the data. So I know that 15 of the 25, or if I make that into a fraction on my calculator, 15 over 25. So it looks like here, 0.6 or 60%. So here, 60% of the data lies within one standard deviation of the mean. So some questions will ask you how many, other questions will ask you what percent.